It stands on nothing, no land, no bedrock, just sea, emptied and rebuilt around it.
321 meters, built on an artificial island in the Arabian Sea in 5 years. This was the site in 1994. Open water, not a piling, not a grain of dry land.
The first thing that hits you, walking across this bridge, is that the ground under the hotel was created by humans. The sea didn't want to give this up.
Sheikh Mohammed wanted one image, one building, something the world would know before it knew Dubai. Architect Tom Wright drew the concept in 1993, a dhow sail, one of the oldest shapes in Arab seafaring. Designed by Atkins, built by Murray and Roberts and Al Habtoor Engineering, 2,000 workers, $1 billion.
Before one beam went up, workers had to build the ground beneath it from scratch, in open sea.
230 concrete piles. 3 years to build the island, then less than 3 to build the tower.
The most photographed hotel on Earth, built step by step, starting with the seafloor.
July 8, 1994. Position marked with buoys, 280 meters from the beach. Nothing exists yet.
A pile-driving barge anchors over the seabed. Workers rig the hydraulic hammer. First pile ready. Each pile, 40 meters long, 1.5 meters in diameter, 230 of them, all into the seabed.
The hammer strikes. Each blow drives deeper through sand, through silt, down toward bedrock.
Bedrock is over 180 meters down, too deep. The piles must grip the sand itself. There is no bedrock to land on. Friction piles only, gripping the sand along their full 40-meter length. Slowly, a forest of concrete grows from the sea, pile by pile. Temporary sheet piles ring the footprint. They hold back the sea while the permanent island builds inside. Rock buns dropped on both sides. The island edge has to resist 100-year storm waves.
Standing in a boat surrounded by these pile heads, you realize the island doesn't exist yet.
These are the roots of a building, not a foundation for land.
Concrete shed armor blocks around the perimeter, first time in Gulf construction, designed to absorb wave energy.
2 rigs working simultaneously, 230 piles to drive. The schedule allows no waiting. Every pile load tested before the raft goes on. 1 weak pile here and 70,000 tons shifts. 230 piles complete, the seafloor rearranged. Now the land itself must be created. Hydraulic fill pumped between the pile walls, sand and water sprayed in until the sea is displaced.
Workers measure the fill level every hour. Too fast and the sheet piles buckle. Too slow and the schedule breaks. Over weeks, the slurry settles, the water drains, and for the first time, land appears where only sea existed.
Vibratory compaction probes driven into the fill. Loose saturated sand can't carry a building. This forces it dense.
Armor rock laid over the fill surface, large enough to resist waves, heavy enough to stay.
This ground didn't exist 3 months ago. I'm standing on sand that was seabed.
The Arabian Gulf is right there, held back by those blocks.
The seawall rises to 7.5 meters above sea level. The lowest floors sit behind this wall.
Drainage pipes buried in the fill. Groundwater has to go somewhere. These pipes control where. The island is formed, 7.5 meters above the Gulf. 3 years of work to create ground that didn't exist. Pile heads trimmed to exact level. The raft must sit flat. Every pile cut to within 5 millimeters. Blinding concrete poured over the full base, The floor workers will stand on, also part of the structure. Waterproof membrane heat welded over the full base. The Gulf will try to push water up through here for 100 years.
Raft formwork goes up around the perimeter. 70,000 tons of concrete, marked out in timber and steel. The island is ready, dry, stable, waterproofed. 2 years of sea work for this platform in the Gulf.
The rebar starts, hundreds of workers tying steel across the full footprint. This cage becomes the skeleton of the raft.
Every pile head wrapped in rebar. The raft grips every pile, load shared between all 230.
Pile cap cages lowered over each cluster. The cap distributes column load between piles, every tie made by hand.
The first concrete pour begins. 70,000 cubic meters. The pour starts, and it does not stop. Vibrators driven through every pour. A void in this raft is a fault the building sits on, every centimeter covered. Night shift. The pour continues. Any stop means a cold joint. A weak plane, forever. Laser-guided screeds drag the surface flat. Every column that rises from this starts from the same plane.
Cooling pipes cast inside the raft. Concrete generates heat as it sets. Without these pipes, it cracks from within.
Temperature logged every hour. Keep the interior below 70 degrees. The pipes run cold water for weeks.
Wet Hessian burlap across the full surface. Too fast, it shrinks. Too dry, it cracks. Water stop joints cut at calculated intervals. The raft expands and contracts with temperature. The joints let it move safely.
More than 70,000 tons of concrete, poured in one continuous operation on an island humans made. And the building hasn't started yet.
Column starter bars drilled and grouted into the raft, every location set from the building's survey grid.
Epoxy coating sealed over the full raft. Seawater and salt air. For 100 years.
The raft is complete. 230 piles below, 70,000 tons above. Now the hotel rises.
Jump formwork assembled at the core. It climbs the building as the walls rise. No scaffolding from ground to top. First core wall pour. Every floor, every load, every storm force, carried by what's being poured right now.
Jump form jacks up. The formwork lifts itself floor by floor. Workers ride it up the building they're building.
Table forms fly into position, each 18 meters long. No shoring from below, they hang from the wall.
Post-tension tendon ducts across every slab. Mindheart International re-engineered every floor. Less steel, faster cycle.
After the pour, these tendons get stressed and the slab grips itself. Tendons stressed from the slab edge.
Table forms stripped and flown to the next floor. Same form, next floor, every time.
Floor by floor, pour, stress, strip, fly, forms up. Workers do it 56 times. Exoskeleton anchor plates cast into the core walls. The steel frame bolts here, precisely located once, forever.
Halfway up, the V-shape unmistakable from the air, the sail hasn't arrived, but the mast already reads true.
Workers pour the final core walls at 250 meters, the Gulf 400 meters in every direction, nowhere to step back to.
The core stands 321 meters above the sea, 130,000 tons on 230 piles in the 9,000 tons of structural steel by barge. The exoskeleton and the outer frame starts here.
First exoskeleton beam lifted into position, bolted to the anchor plates cast weeks earlier. The outer frame begins.
Workers climb the exoskeleton face. No elevator, no scaffolding, just the steel grid, and a harness over the Gulf.
This steel on the outside isn't decoration, it's structure. The whole building leans on this frame when the Gulf wind hits it. Welcome to our new facility. These steel supports provide incredible stability. It is quite impressive.
The Burj Al Arab. Built from the sea, built for the ages, one step at a time.